Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Very good evening. This is Anand Misra. I am PhD student at IIIT Hyderabad. I am going to talk about a probabilistic model for scene text recognition. This is joint work with C.V. Jawahar and Karthik Alhari. Okay, so optical character recognition, OCR, is one of the most successful application for of machine learning. On the other hand, recognizing these sort of images taken from street views is a challenging task as compared to the scanned documents. This is challenging because of the variations in fonts, hence fancy fonts, color variation, foreground and background variation, and due to the projection. Unlike scanned documents, a good segmentation for this sort of word images is not trivial. And the extraction of characters is not an easy task for these images. Whereas even if we extract the characters out, unfortunately isolated character recognition accuracies for the natural characters are very low. It's worth mentioning here, Manik is here, he has a data set called character 74K, which has very low accuracy as compared to the handwritten data sets like MNST, where the machine learning community shows or machine learning community achieves the accuracy of close to 100. For natural characters, the accuracies are really low, in somewhere 60s. So if even if we segment the characters out, since the character recognition accuracies are low, the word recognition will be going to be further low. The second way of thinking, formulating this problem of recognizing words is to form it as a multi-class classification problem, where given a word, we want to learn some feature at the word level and recognize the word as a whole. But unfortunately, this is also not feasible for this sort of images, because we do not have sufficient training data to train these sort of images. So we need something better. So we follow a different path. Instead of relying on the hard segmentation, we run a sliding window based approach for a given word and train the SVM classifier at character level. After training this SVM classifier, we obtain many character windows, and we form a graph which looks something like this. Now the problem of recognizing this word becomes same as inferring from this probabilistic model. So one can infer this path and get DCXR, one can infer this path and get DOR, or one can infer this path and get DCCR. So obviously there are many labelings possible. The question here is, which one is the optimal? In general, the problem is NP hard. However, we solve the approximate version of this problem by defining an energy function of this form. The energy function we define in such a way that the minimum of this energy corresponds to the optimal word. This energy function has three terms: unary, pairwise, and the higher order terms. And this energy function is popularly known as conditional random field energy function. So we have three terms here. The unary term comes from the agreement from the SVM classifier. So let's say SVM classifier say correct this window to be A with 0.9 probability, then there is a low cost for that window to take label A. We have a pairwise term which is both lexicon based and overlap based. Lexicon based pairwise terms are in the intuition that there are certain characters which are more likely to come together. There are certain characters which rarely comes together in English. So we model this joint probability as the pairwise term. Similarly, we have overlap based term. This is mainly because to ensure the two highly overlapping nodes are not going to take non-null label. So if two nodes are highly overlapped, then one has to take null label. We also introduce higher order terms in the CRF. Introduction of higher order terms in CRF is not trivial extension of pairwise. So for modeling higher order terms, what we do is we add an auxiliary node to all the nodes in the clique of size h, where h is the order of CRF, and we decompose the higher order terms into the unary and pairwise term, where the unary terms comes from the probability distribution. So as a trivial example, as a toy example, we can consider this picture where this unary terms recognize this word as CPFN. However, we add an auxiliary node and we say that OPE comes very frequently in the dictionary, so there is a low cost for that. However, CPE has high cost. Similarly, PFN has a high cost. Introducing these higher order terms allows us to recognize this word correctly as open. Okay. So we also investigate in various ways of computing priors. So the popular bigram based priors are nothing but the joint probabilities of characters pairs occurring together. We also work with node specific priors. Node specific priors are something comes from the intuition that few characters in the English language comes towards the start of the word, few characters towards the end. So for this example, so node specific priors are dependent on the spatial position of the word, and we actually experimentally show that node specific priors is slightly better than bigram prior. Once we define this energy, our task is to find the minimum of this energy. For this, we use tree-related message passing scheme, and thanks to Kolmogorov and all, we have efficient implementation for this inference. These are some qualitative results where we can see we perform very good on variety of images with various fonts, style, contrast, and even in fancy fonts. These are some numeric results where we compare our methods with the previously published work on this direction on two public data sets, that is SPT Word and IGDAR 2K3. That is, these are the two most challenging public data sets for this task. We also introduced a IIIT 5000 word data set for evaluation word recognition accuracy, and we performed better than the previously published methods and the commercial OCR AB 9.0. Okay, to summarize, we have a principled framework for syntax recognition. We do joint inferencing to detect two characters and recognize word as a whole. We also introduce novel higher order potentials in the CRF to model n-gram based information which is there in the language. As an ongoing work, we are working towards detecting text from the images taken in the wild, and since the character recognition accuracies for these sort of characters are low, we are also working for the better features and better learning scheme for scene character classification. Thank you very much.